Welcome back to my channel Math School. In today's video, let us solve example 18 from chapter 3, pair of linear equations in two variables. In my previous videos, I've completed the examples 1 to 6 and 11 to 17, exercises 3.1, 3.2 and 3.4. If you have not watched these videos, do find the link in the description box below or click the I button above. So now quickly let us begin with the video. Example 18 from chapter 3, pair of linear equation in two variables says, solve the following pair of equations by reducing them to pair of linear equations. So here they have given us two equations. First we have to reduce them to a pair of linear equation and then we have to solve them and find out their solutions. Like how we did our previous example, that is example 17, it is very much similar to that example. So first let me write down the general pair of linear equation which is given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c1 c2 equal to 0. Right? So these are the pair of linear equation which is written in general form, or they can be written as ax plus by plus c equal to 0. So this is the standard form where we can represent a linear equation. So let us try to reduce these two equations in general form of a linear equation. So the first equation given here is 5 by x minus y plus 1 by y minus 2 equal to 2. So let us try to separate the numerator and denominator and let us write down in this form, that is 5 into 1 by x minus 1 plus 1 into 1 by y minus 2 equal to 2. Now similarly let us do with the second equation given. Let us separate the numerator and denominator here. 6 into 1 by x minus 1 minus 3 into 1 by y minus 2 equal to 1. So here you can observe that in both the equations we have the same variables, that is 1 by x minus 1 and 1 by y minus 2. Right? So let us now substitute 1 by x minus 1 equal to some other variable like p, and let us substitute 1 by y minus 2 equal to q. So write down, since these equations are not in the form of ax plus by plus c equal to 0, so therefore let us substitute p equal to 1 by x minus 1 and q equal to 1 by y minus 2. Right? So let us substitute this in these two equations. So from the first equation we get 5 into p, 5p plus 1q. Substituting 1 by y minus 2 as q. So we get 5p plus 1q equal to 2. So let us take this as equation 1. Similarly, in the second equation, substituting 1 by x minus 1 as equal to p and 1 by y minus 2 as equal to 2, we get 6p minus 3q equal to 1. So this be equation number 2. So we have got the two pair of linear equations. Now let us apply here the elimination method to find the solutions. So the first step to apply elimination method is we should make sure that the variable we want to eliminate, it should have the same coefficients in both the equations. So here let us try to eliminate the q variable. So therefore we have to make sure that the coefficients are equal. Here we have 1q in equation 1 and in equation 2 we have 3q. So let us multiply equation 1 with 3 so that the coefficient of q becomes equal into 3. So we get 5 into 3 will be 15p plus 3 into 2 as equal to 6. Now the second equation will be as it is, that is 6p minus 3q equal to 1. Now the second step in elimination method is that we have to make sure that the signs are plus and minus for the variable we want to eliminate. So here we already have the signs as plus 3q and minus 3q, so no need to change the sign here, right? So we can eliminate plus 3q and minus 3q and we are left with plus 15p and plus 6p. So let us add this. So we get 21p equal to 6 plus 1 is 7, right? So therefore P is equal to 7 divided by 21. So cancelling 7 one time, 7 3 times. So we got here P value is equal to 1 by 3. Now let us substitute this P value in equation 1 or 2. So let us substitute P equal to 1 by 3 in equation 2. So taking equation 2, which is 6P minus 3Q is equal to 1. So 6 into P is 1 by 3 minus 3Q equal to 1. So 3 1 times, 3 2 times. So we get 2 minus 3Q is equal to 1, or sending this minus 3Q to right hand side and bringing this 1 to left hand side, we get 2 minus 1 is equal to 3Q. The signs will change. 2 minus 1 is how much? Again it is 1 is equal to 3Q, or Q is equal to again 1 by 3. So we got P is equal to 1 by 3 and Q is equal to 1 by 3. Now what is the P value which we had assumed initially? We had assumed P to be equal to 1 by x minus 1. So let us substitute here. Write down, since P equal to 1 by 3 and P is equal to 1 by x minus 1. Therefore we can equate 1 by 3 equal to 1 by x minus 1. 1 by 3 is equal to 1 by x minus 1. So let us cross multiply here. So 3 into 1 will be 3 equal to x minus 1 into 1 will be x minus 1. So let us send this minus 1 to left hand side. So you will get x equal to, so 3 plus 1 equal to x, or therefore we can write x is equal to 3 plus 1 is 4. So we got x value. Similarly, now we have obtained Q value is equal to 1 by 3, and also we had taken Q as equal to 1 by y minus 2. So write down Q is equal to 1 by 3 and Q is equal to 1 by y minus 2. Since left hand side value is equal, even the right hand side will be equal. So we can write 1 by 3 equal to 1 by y minus 2. So cross multiplying, we get y minus 2 into 1 equal to 3 into 1 is again 3. So let us send this minus 2 to right hand side. So we get y is equal to 3 plus 2, or y is equal to 5, right? So we got x value as equal to 4 and y value is equal to 5. Now you can verify this answer by substituting the values in the given equation. So if I consider the first equation, 5 by x minus 1 plus 1 by y minus 2 is equal to 2. So 5 divided by what is x value we got, that is 4 minus 1, plus 1 divided by y is, we got 5 minus 2. So this will be 5 by 4 minus 1 is 3, plus 1 divided by 5 minus 2 is also 3. Since the denominators are same, we can add the numerators, that is 5 plus 1. What is 5 plus 1 is nothing but 6 by 3. So cancelling 3 1 times, 3 2 times. So we got the value as equal to 2, which is equal to the right hand side, right? So the answers are verified. So the value x is equal to 4 and y is equal to 5 is verified in this manner. You can also verify in the second equation in the similar way. So therefore you can say x equal to 4 and y is equal to 5 is the solution for the given pair of equations, right? So this is how we solve this problem. If you have any further doubts, do comment me below in the comment section. In my next video, I'll be solving example number 19 from chapter 3, pair of linear equations in 2 variables. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT math. And also do watch the related videos of chapter 3, pair of linear equations shown on the screen. Thank you.